What volume of 1.5 molar sodium hydroxide solution is required to completely neutralize 250 milliliters of 4.0 molar sulfuric acid? Now, for some of you out there, the first thing that you're going to think about is, oh, okay, well, this is going to be simple because I know that the number of moles of acid will equal the number of moles of base when it comes into neutralization. However, I hate to break it to you. Actually, I don't hate to break it to you. This is not necessarily always correct. What you're actually doing is what you're wanting to do for a neutralization reaction is equaling the number of protons with the number of hydroxides. Now, this isn't necessarily the same thing as saying the number of moles of acid equal the number of moles of base. For some times it might be the case, but in this case it's not. You need to have a balanced reaction equation first to determine complete neutralization. For sodium hydroxide, that's simply NaOH. But sulfuric acid, that's the headache. That's H2SO4. So when I go through and determine what my product is going to be, I know that since this is an acid and a base, I'll be making at least water. Now, for those of you who've never seen my videos before, notice that rather than writing down H2O as water, I like to write down water as HOH so that I can see one proton came from the acid and the OH came from the base. HOH or H2O, they're the same thing. I'm also going to add in my salt because an acid plus a base always yields a salt and water. The salt is going to be a combination of my sodium ion and my sulfate ion, which will be Na2SO4. And when I go through and balance, I have 2 protons and 1 hydroxide on the left. I'm going to need 2 waters on the right-hand side. Notice also that on the right-hand side I have 2 sodiums, so I'm going to need to put 2 in front of my sodium hydroxide. And now that you should see that the number of moles of acid, which is 1, is not equivalent to the number of moles of base, which is 2. So what we need to determine is first going to be, do we know the number of moles of acid, or do we know the number of moles of protons? Do we know the number of moles of hydroxides? And if we look, we do know the number of moles of acid because I have a concentration and I have a volume. And I know that molarity is equal to number of moles over the volume in liters. So I can simply say that the number of moles is equal to molarity times my volume in liters. So the number of moles of my sulfuric acid will simply be 4.0 molar times 0.250 liters, which is going to be a value of 1.000 moles to 2 sig figs. So this is the number of moles of sulfuric acid I have. And as I mentioned earlier, we do not care about moles of acid, we care more about the number of moles of protons. So if I look at H2SO4 and I break down H2SO4, I'll have 1 sulfate ion, but I will also have 2 protons. So my 1.000 moles of my sulfuric acid, I can convert that. For every 1 mole of my acid, I will have 2 moles of my protons. So technically I have, nope, that's not right. So technically I'll have 2.0 moles of my protons to 2 sig figs. And since I know the number of moles of my protons, I can now say that the number of moles of hydroxide, which I said were the number of moles of protons in order for us to have full neutralization, will be 2.00 moles of OH negative. Now, the question was asking more about the sodium hydroxide concentration, but since we know the number of moles of hydroxide, I can easily find out the number of moles of sodium hydroxide. Because if I was to break up sodium hydroxide, 1 sodium for every 1 hydroxide, just based off of what the chemical makeup of, or the chemical formula for NaOH is. So, for every 1 mole of OH negative, I will have 1 mole of my NaOH, which means 2.00 to 2 sig figs moles of my sodium hydroxide. So let's break this down. I went from my concentration and volume of sulfuric acid to moles of sulfuric acid to moles of protons, and because moles of protons equals moles of hydroxides to neutralize our acid-base reaction, I know the number of moles of hydroxide, then number of moles of sodium hydroxide. And finally, I can determine the volume based off of a concentration, because I can use that molarity formula and say that volume is simply going to be the number of moles over my molarity. So 2.00 molar 2.00 moles to 2 sig figs, divided by 1.5 molar for 2 sig figs as well, is a value of 1.333 liters to 2 sig figs, or 1.3 liters. However, this could be also reported in milliliters as well, because they did give us a milliliters of sulfuric acid. So also make sure you convert this to milliliters if need be, which will be 1.3 times 10 to the third milliliters. Either answer will work because you can easily transfer over those units. But please remember, the key to this, anytime that you're neutralizing an acid and a base, do not remember moles of acid equal moles of base. What you need to remember is moles of protons from the acid equal moles of hydroxides from the base. Because in case you run into sulfuric acid or any type of base that has more than one hydroxide, you're going to be wrong. It's always moles of protons equals moles of hydroxide.